Okay, so internal performance test of an internal combustion engine for MLab2. So, at ito yung equipment pang test. Ayun yung diesel engine at ito yung mga equipment, measuring instrument. So, ito yung isang sample din ng internal combustion engine. So, engine performance. The forms of indicator cards, which are instrument drawn PBs from running engines, are shown in Figure 1 for both 2 and 4 cycle types. A diesel engine is used as a source of power, which can utilize a relatively cheap fuel. Therefore, its power capacity and thermal efficiency are paramount engineering consideration. So the developed cylinder power is the indicated horsepower, abbreviated as ISP. After engine friction and accessory power needs have been satisfied or binawas mo doon. The net power available at the engine shop is the brake horsepower, BHP, so-called because it can be, but nowadays seldom is, measured by a brake dynamometer. Indicated power is difficult to measure directly on a small diesel with good accuracy because the volume of indicator laid to the cylinder head appreciably lowers the normal compression ratio. Also, the cylinder heads of a small bore high-speed engine have special chambers, valves, and other equipment, leaving little or no space available for an indicator lead. Since none of these difficulties exist with the large stationary diesel, indicator openings are provided as standard equipment for large. A hypothetical pressure known as brake main effective pressure BMEP can be employed to show the magnitude of main effective pressure. The true pressure, PMEP or IMEP, is higher on account of engine friction loss. So ISP is equal to PMEP, LE, and sub P over 33,000 in horsepower. Horsepower is the unit of this ISP. VSP is the 2 pi WRN over 33,000 SP. So, and brake main effective pressure is BSP times 33,000 over LE&P pounds per square foot. Okay. This is English units. For SI units, so that is ano lang, torque times the speed, angular speed. And this is also pressure times volume. So in which yan, mga symbols, PMEP indicated MEP, pounds per square foot. L, piston stroke. A, piston pace area. N sub P is the number of power stroke per minute. N is the rotative speed. W is net dynamometer force in pounds. R is dynamometer arm length. Okay. So NP is equal to 1/2 for NP is equal to N for 2 stroke, and NP is equal to 1/2 of N for 4 stroke. So as is true of all prime mover, there are a number of efficiency expressions applying to G cells. Mechanical efficiency is the ratio of BHP over ISP. Indicated thermal efficiency, NTI, is 2545 over WIQ, and brake thermal efficiency is NTB is equal to 2545 divided by WBQ. 2545 BTU per hour, horsepower hour. In this WB is the fuel consumption, pounds per hour per ISP or BHP. Q is the fuel heating value, BTU per pound, either QS or QL according to policy. So example number 1. 6-cylinder diesel engine on dynamometer test was found to use 84 pounds of fuel, having QS as 19,351 BTU per pound in 1 hour. So 84 pounds per hour at steady state. So the brake thermal efficiency and the brake MEP will be determined from the following test data and measurements. So ito yung mga na-measure mo, di ba? So cylinder is 8.5 inch by 10.5 inch in 4 cycle type. Speed is 600 RPM. Dynamometer torque is 1809 pound-foot. Ito yung na-measure din to. So given WR is equal to dynamometer torque 1809 pound per foot QH is 13,351 BTU per pound, N is equal to 600 RPM, D is equal to 8.5 inch is 0.7083 feet, L is equal to 10.5 inch is 0.875 feet, fuel weight is 84 pounds per cycle type. Okay, ang mga na-measure mo dito is yung dynamometer torque and the fuel weight in 1 hour. Okay, required brake thermal efficiency and the brake MEP. Solution, tunayan mo yung BHP is equal to 2 pi WRN over 33,000 horsepower. So, 2 pi times 1809 yung WR times 600 over 33,000 is 206.7 horsepower. The brake thermal efficiency NTS is equal to 2545 over WBQ. So, WBQ is equal to 84 over 206.7 is 0.4064 pounds per horsepower hour kasi 84 pounds per hour na yan. NTB is equal to 2545 over 0.4064 divided by 19,351 is 0.324 or 32.4%. And brake MEP is equal to BSP times 33,000 divided by LANP pounds per square foot. So area is pi D squared over 4 times number of cylinder. So NSOP is equal to N over 2 for 4 cycles. So BMEP is equal to 206.7 times 33,000 over 0.875 yung L mo. Then pi over 4 times 0.708 T squared times 6 times 600 over 2 is the 10,991 pounds per square foot. So the brake MEP is equal to 10,991 over 144 is 76.33 PSI. So this is now your answer. The energy supplied to IC engine in the form of QH of fuel input is generally broken down into the following items for heat balance purposes. So sa heat balance tayo, 1. Useful works is the actual net shaft output. 2. Cooling, heat absorbed by water jacket. Sometimes this is not separable from some of the friction and exertion loss due to merging stream of water that cool cylinder, exhaust manifold, and lube oil. Heat exchanger, yung total niyan. WC delta T type of loss. 3. Exhaust gas loss. Heat carried off as sensible and latent heat in the product of combustion. Sensible heat is WC delta T loss. Latent heat is of the form 2442.7 times 9H2 times and kilojoules per kilogram. 4. Mechanical friction. Crankshaft and connecting rod bearings, piston, etc. Usually taken into include energy supplied to engine-mounted accessories such as pumps, governor. Number 5, radiation and unaccounted for, which is heat radiated from engine and incomplete combustion loss due to presence of fuel and exhaust gas. Items 4 and 5 are not often separable nor measurable. They are usually combined, then the balance is made by subtracting items 1, 2, and 3 from the heat of the fuel and considering the difference to be items 4 and 5. So this is the typical Bollard heat balance percent on based on QH. So useful works, ito yung auto cycle, spark ignition, diesel cycle is compression ignition. So sa diesel tayo, so is 34%, cooling is 30%, exhaust is 26%, friction, radiation, and unaccounted for is 10%, input, heating value of fuel is 100%. So tawag mo to. Auto engine, ito naman. Okay, if na may given ka ng work, divide mo ng 0.34, makukuha mo yung QA. So QA, makukuha mo, multiply mo ng 0.3, makukuha mo yung heat loss. Saka yung exhaust loss, 0.26 times yung QA. Diba? So this is just a typical full load heat balance. So sa actual, so yung ano yun, detail na yun. Gagamit ka na nitong isa. Ayan. Okay? So ito lang ang sa internal combustion engine. So, andyan siya. Magte-testing.